Homework has become difficult because when you use online resources, the homework and submissions are too good. So, we have two people. Oh, so Pooja is here. Yeah. If you're in contact with Sanya, you can tell her that that's available.
Yeah, I put it in the group chat that we're all in.
Okay, so you put the number or
I at this point have it memorized now since I typed it in so many times.
I don't know. We have some. So when you use online resources, how does it work? Like, do you guys ask the question? Let's say if you want to take online resource for a question that I give, do you ask it in your own words, or do you take a picture and submit it, or how does it work? What's the easiest way?
I'd imagine probably the easiest way is there are like AI tools where you can just take a picture of the problem and then submit it. That's
what I did, and like like the midterm exam that I made. I thought, okay, let me see how does this AI do. I took a picture and posted it and said solve this, and it did great job. Yeah, I would have given it 100 out of 100. So, but I was thinking, is that the best way, or is there any other way?
I think for our actual problem, we have to do ourselves first, then after we submit and then ask it to check if anything wrong and then give the solution.
No, that's all how you do it. But I'm saying, suppose, tell me the worst that can happen.
Easiest way is just take a picture.
Yeah, easiest way is you can have ChatGPT do your entire assignment for you.
And it does good. That's at least to my, because I thought I made my own question, so that might be hard for the AI that doesn't exist, but it did a great job. Yeah. Oh yeah, so I have to say about the exam for next week. I did think about it. Fine, go all the way to here, right? Yes. Yeah. One. Okay. There was a homework due today that I think is, since I messed up so much last time, I postponed it to Monday, or even, yeah, let's make it Monday. You should be able to do it today also, because all these doesn't really affect it. So this was the due date. But now let's make it 1, 2, 3. And exam. And what are the questions? This is roughly what it is. First of all, it's cumulative. This is only a proposition. I might change this, what I plan to do here. This will be based on homework 6. Based on, right? So if you just make sure that you understand how to do all, there are 2 problems in homework 6. If you, some variation of that, or significant variations of that is possible. Basically, quantum mechanics. 2 is on Fourier. That's the next homework. Third one on Green's function. And all this will be small problems, like the homework problems are sufficiently lengthy, but I'll small homework can be broken into smaller pieces, right? So some small piece out of the homework. So if you know everything that went along, all the arguments that was necessary to do the homework, then you should be good. But there are lots of ifs and buts in the homework. So all the arguments is what you want to go through. Green's function, same thing, small pieces. And fourth one is on Legendre polynomials, even that small piece. Fifth one will also be on, so this is take home, right? But that will be on, or bring from home, maybe. Bring from home, that will be on Legendre polynomial. And I was earlier thinking of making this a longer problem, but I think it'll make it short. It won't be significantly long. Yeah, that's what I have, I guess. Anything else you can think of? Yes, yeah.
So, you based, or were you saying that this could be, or not could be, it is cumulative, so.
Yeah, it is cumulative, so that's what, this is my guideline. I have questions I want to ask on this, but let's say that when I'm really phrasing the question, I realize that, oh, this is too hard. Or this is, for some reason, I don't like the question. Then I'll bring something from cumulative, so I want to keep that option open.
Okay,
Is that clear?
yeah,
So currently, this is my plan, tentative plan. But it is a cumulative exam, so you are expected to know everything.
okay. So, maybe the question, a real question I should be asking was, like, say we come Monday, will you let us know that, hey, maybe one of these is too far and I switched it, or?
No, because my motivation is also that you study.
Okay, yeah, that's what I was figuring. But
Right, so that at least go over what that is. That's my, I mean, that's one of the motivations, that you don't forget the content that's
Okay.
already going on.
So don't expect.
But this is what is like 80%, this is what is going to be there. But 20% chance, that is it.
I just want to make sure that it wasn't 100% going to be these 5 topics. Everything else is still.
Yes.
Okay, yeah.
Yes. Yeah.
I think like last time, before the exam date, like Thursday, if we go for the 1 hour, like at the evening for the group meeting, like in June.
Oh, yeah, last time we did this, right? I forgot about it.
Yeah,
Was
that one
useful?
is way good for us because
Okay, yeah.
most of the thing we did, and then whatever we did, and we repeat and repeat. But when you explain over here, we already did that. When you explain over here, after that, actually for me, for that, I didn't open that topic. I study other topic after that. That's why I think that one is like.
Sure, I can do that. Do we have to do this online?
Online, in person or online, whatever.
Yeah, I like it in person, but evening online, in person is possible for you guys?
What is?
The suggestion is that last time, I don't know whether you were there or not, right before the day of the exam. On the evening, I think it was at 8 o'clock or 7 o'clock or 8 o'clock in the evening. There was a review session, or not really review, just an question answer session. You ask questions and I'll answer it. And the point is that it was very productive because you were prepared already. And then when I'm working on it, then it is very productive. Like I can see the benefit of it and I'm willing to do that. But it would be nicer if it is, if we are available here. But I can open the online option surely, because everyone, I don't think it's convenient to reach here, right? In the after evening, like buses, do the buses run?
I'll be here. I think I was here last time, personally.
Yeah, you were there, but I don't remember completely. I think Yeah, I think you were the only one. there,
Yeah,
is
I'm
that
the
correct?
only one.
Yeah, you were the only one because you were working on the. Yes, that's probably. Yeah. Yeah, so let's because I know you guys don't have buses, so okay, so online is totally open, but I'll encourage you guys to again.
Okay, we'll
Come here.
try to come here.
Or put it like this, I did not enjoy that session, even though I can understand you benefited. Just because there was no one, I don't see faces. Or if you're there, at least put on your camera. Right, so that's the minimal I would require, but I don't want to make it force it because it's a house, you will be opening the camera, I see your a background, I'm not interested in your kitchen or something, but it really helps to have a face when I ask questions and you respond. Yeah. So, okay. Okay, so any other questions?
I think that should be good.
Thane and Puza, is there any comment on what we were discussing? If the volume works?
No comment.
Yes, the volume works, no comments.
Did you understand?
Yeah, if it is working, no comment.
Oh, it's-
They agree with us.
okay, okay. Okay. On Monday, let's make this more concrete, but I'm yes for it, yeah. But the details we can talk, yeah. And it will be a Thursday, right? So I have to make sure that I'm
Yeah,
available.
Okay.
I don't book anything.
Wednesday or Thursday, any day is okay.
Even Wednesday is good, so ahead of time, will you be prepared?
Yeah.
Okay. That'll be better, okay. So Wednesday. So if that is the case, why don't we do it in the morning of Thursday?
We can do that.
Then everyone is there on campus.
Thursday morning, yeah. And one.
I won't be able to be there, but that's okay.
Oh, because you're not available any of the hours, or
I-
you're working.
I teach from 9 to 11.
Okay, so let's just evening, so. Okay, we'll see. Okay, going back to any other questions before we go? Last time I was trying to get an expression, I think it's called the Rodrigues formula for the Legendre polynomials, and I think I messed up sufficiently, so I think I'm going to repeat that whole today. So that's the reason why I postponed the homework also, and I'll cover this until the midterm too. So even on Monday, I'll keep doing Legendre polynomials. So we lose a lecture or two, but I think we catch up on something else. So I'll lose something on spherical decimal functions. Okay. So we were talking about Legendre polynomials. And it is defined using the idea that if you have a potential due to a point charge or a point mass based on whether it is Q1, Q2 or M1, M2 in the numerator, it is either the electric potential or the gravitational potential due to a point mass or a point charge. So that's what it is. This can be written as expanded out. This is R squared plus R prime squared minus 2 times R prime times cosine of gamma. And the cosine of gamma is equal to R hat factored with R hat prime. That's the angle between. Make some more definitions. Have R greater. So R greater is maximum of R and R prime, and less is minimum of R and R prime. I think that's a notation we are using. If I pull out the R prime, so this becomes 1 plus R less over R greater minus 2 times R less over times, let's say X is the sine gamma. if I call less over r greater, that's t, and this is 1 plus t square minus 2 tx. So that's what we call the generating function for so this is just so this whole thing here, that's g of tx. That's a idea. And if I expand this as a series in t, there are two variables in this. Expand the t as a series. And I get so L equal to 0, infinity t raised to L times whatever is a coefficient, that's what we call. The coefficient can depend on x, because if I expand it in terms of t, then whatever is remaining will be x. And this is Legendre polynomial of degree. So that's it. Definition. And we already tried to evaluate this for 0, 1, 2, 3, some elementary ones, but it is good to have a generic expression. And so today what we will do is, or we tried this on Monday, and I sort of messed up at various places. It was not nice. So I'll just expand this again. So we just expand it as a series. So remember your series expansion, 1 plus y square root is equal to 1 plus y raised to minus half. Okay, expand this. So you get first term is 1 plus the power is minus half and over 1 factorial, and then raised to y raised to 1 plus minus half times minus half minus 1 provided by 2 factorial and y square, and you keep doing that, right? And minus 1 and minus 2 over n factorial. This is the same as sum over y raised to m. So this is let's say n equal to 0 to infinity, and the power goes from 0, then there is a negative or positive, negative, positive, negative. So it changes the sign. So it is minus 1 raised to n. Then we have 1 over n factorial for sure. That's a denominator. That is y raised to n. And this can be written as minus, there's a half, then half times 3 half. So that is the pattern that we are seeing is 1 by 2. This 1 by 2 plus 1. And then there is 1 by 2 plus 2 and so on. So this is the same as 1 over 2 raised to n. And the numerator, this comes out to be 1 times 3 times 5 times. How far do you go? So this comes with 1, this comes with 3, the next one comes with 5, and so on. So how can I do that? So first thing is, how far does it go? It depends on whether it is even or odd. So I multiply this, maybe help me again. So this is it is 1 goes until 1. How should I say this?
0 plus 1 by the numerator.
Write this better. So it starts with 1 by 2, then it is 1 by 2 and 3 by 2. Well, then it is 1 by 2 times 3 by 2 times 5 by 2 and so on. So that's the pattern. So this is m equal to 0, n equal to 0, that's 1, that's 2. And you notice that I can do the following. I start from 1, multiply by 2 all the way in the denominator, so that's 2, 3. And how far should I go? Here I'm going to 3, so it is 2 times m I'm going to go. So that's m equal to 0 or n equal to 0, right? That's n equal to 0. So when n is equal to no. Again, I stop.
Why is it not 2n plus 1?
Let me tell you. Okay, so this is. Let's do this here properly. Okay, n equal to 0, n equal to 1, n equal to 2, and so on, right? So this is surely 1.
1, yeah.
This is 1 by 2. So this is 1 by 2 times 3 by 2. Right? N equal to 3. One more, let's do. 1 by 2, 3 by 2, 5 by 2. I think that should be sufficient, I suppose. So this is 0.
Yeah.
Right. Okay. So let me write the denominator as 2 raised to n. So this is 1, this is 2, that's 2 raised to 2, that's 2 raised to 3. That captures it, right? In the numerator, let me write this as 2n factorial, and then divide this by 2 raised to n. So I say this captures everything. So let's see, for n equal to 1, I have 2 factorial, but then there is also this denominator 2 that cancels out. So that's 1. And the next one, so for n equal to 2, this is 4 factorial divided by 4. That's equal to 2 and 2, how do you say this? 1, 2, 3, 4,
That is
divided by 4. And
there is 2, 4, I guess. 2 to the power n, 2 to the power n. 1 is 4, 1 is 4. 4 into 4.
tell me again?
Into 10.
Oh, yeah, there is another 2 raised to n, right? So 4 squared. Yeah, that's what I was missing.
Yeah, 4,
Thank
4
you.
cancel. 2, 1 by 2, 3 by 2, that works.
2, so that's 1 times 3, 1 by
1 by
2.
2, 3 by 2.
That is a 3 by 2.
Oh, yeah, there is 2. 1, 4 is cancelled, that is 3 by 2 and 1 by 2. That is 1 by 4 is remaining over here in the denominator.
Why am I not seeing this again? 1, 2, 3, 4, and then 4 squared. 4
Yeah,
times-
1, 4 cancel, 1, 4 doesn't cancel.
So there's a 2 remaining.
Oh, 1 by 2.
So there's a 1 times 3 divided by 2, right?
Yeah.
But that's not what it is. What if we have it? Okay, let's do this again. Oh, we gotta get this clear. Okay. When n is equal to 0, okay,
That
so
one
this is 0 factorial divided by 1. That's equal to 1. N equal to 1. N equal to 1. So this is 2 factorial divided by 2 times 2.
1 by 2.
So that's 1 by 2. So that works.
Yeah.
Okay. So n equal to 2. This is
4 factorial.
This is 4 factorial divided by 2 raised to 2, that is 4 times 4. That's 1, 2, 3, 4 divided by 4 and a 4. So the 4 cancels out, that's 1 and 3
By
and
2.
by 2, right?
Again.
That doesn't work then, right? Okay. Oh. Because there is an n factorial too.
Yes.
And was that necessary? No, we were n factorial I removed already, correct?
We
Okay.
move with the to the power n with n factorial.
So this doesn't work. And that's because I think this is wrong. Okay. So let's try this. Okay, how did I do this? So I have 1, 3, 5, and I'm proceeding forward and divided by, I think that is for each one that is a 2, correct? Here, that's how it is. So I can always do this as 1, 2, 3, 4, 5 all the way. And then I'm multiplying the 2's also. So this is 2 raised to m. And I want to go to the last one as m. So I'm really doing, oh, it is not. So what I'm doing is 2, 4, 6, and so on, right? Until 2m. That's the same as 2m factorial in the numerator. They now divided by 2 raised to m. So I take a 2 raised to m again, and that is an m factorial remaining.
Okay,
So I was missing the n factorial even after the n factorial here. Right. So my claim is that the actual thing is 2n factorial divided by 2 raised to n square times n factorial.
Yeah.
Now let's try.
I think that makes sense.
Okay, better. Okay, n equal to 0 is, I think this works anyway, so that's 1 and 0 factorial, that's equal to 1. N equal to 1, this is 2 factorial divided by 2 square, and then that is a 2 factorial. Does this work?
It would be 1 factorial, not 2 factorial.
Because n is equal to 1.
Yeah.
Then yeah, that's 1/2.
Yeah, it's
And that's 1/2, that works. And n equal to 2, so 2, so this is 4 factorial divided by n equal to 2, so that's 4 square. And that is a 2 factorial. So that's 4 times 3, because 2 factorial goes away, and then 4, 4. So that's
And that
3
was
over 4, that's and n equal to 3, we want to check if it works. Okay, n equal to 3 since we messed up, or I messed up so much. Okay, so this is 3, so this is 6 factorial divided by 2 raised to 3, that's 8 square. And this is 3 factorial, so that's 6 times 5 times 4 divided by 2 times 3, that's a 3 factorial, and then 8 square. So 3 times 2 goes away, so that's 20 divided by 64. That's 10 by 32, 5 by 16. Doesn't work.
I'm sure the formula is correct and that there might be something wrong here.
Okay, so it's wrong. Again, 6 factorial. 3 into 6 factorial. 2 raised to 3, 2 times 2, 4, 4 times 2, 8, 8 squared. 3 factorial. Okay. So 6 factorial divided by 3 factorial is 4, 5, 6. So 4, 5, 6.
Okay, 3 is.
Oh, so this is not there,
That
right?
3, we didn't need 3 over here. Only 3,
I
and we
think,
have to remember 3.
so this is 8 square.
Yeah,
That's
now it's up.
so that's 20 divided by 60.
It's 120 over 60.
128.
Oh, the 6 I did not. Okay, 6 times 20, 120 divided by 6. Better. And that's 60 divided by 32, 30 divided by 16, 15
Over
divided by
9
8.
or 8.
Yeah.
That works.
Yeah, that works.
Okay. Good. So we have a formula. Sorry about that. But okay, so this is better. So this is 2n factorial over n factorial. So there are 2n factorials, and then there is 2 raised to n. Okay. Okay, sorry about that.
That
The
helps
second
us.
time I'm doing it still.
Yeah, that help us.
Okay,
Sometimes if we stuck, we know the how to check.
yeah,
If we check first and second, we just move. We didn't check third one.
yeah,
Now we know we have to check until 3 and 4.
yeah, I think at least I. Okay, so let's do, so if this is true. What I'll get for y here is, yeah, y is equal to t squared minus 2xt, right? So I have to do y raised to n. So let's also do t squared minus 2xt raised to n. Okay. What is that equal to? A plus b squared, a plus b cubed, these are integers. So that's the same as sum over m. Then just it goes from 0 to n. Like the power, the largest power. And then you start from n factorial divided by, that is a power m factorial, then n minus m. M is always less than m. And now the powers, first power reduces, right? So it reduces down, and the second power increases. Right. So I want to write this as, so
Would that be like e squared to the n minus m and then minus 2xt to the n?
yeah, but that's why I'm wondering how to proceed. Let me do this as minus 2xt plus t squared. Like I can do either one, right? So which variable I want to keep first. So I want to keep this as minus 2xt. This is the power that will go down. So it starts from n. And then it goes down in power. So let's say that's m. Right? So as I increase my m, the power goes down, and the other one increases. That should be correct. Okay. So I just have to be careful which one I pick accordingly. Changes. Okay. So put this all together, and I have g of t comma x is equal to I have n, so this is n equal to 0, infinity, and m equal to 0 to n. And now I have to collect all these things. So surely there is a minus 1 raised to n. There's a minus 1 raised to n here also. And there is a minus 1 raised to minus m, but that is the same as minus 1 raised to m. Isn't that correct? I think Rocky, you had pointed out a mistake last time I messed up, right? So I think this is correct. Think so? So this is minus 1 raised to m. It should be minus m, but minus m and plus m when it is raised to minus m doesn't matter. I think so. So this n factorial cancels out the n factorial here. So that's gone. Then there is y. Y is this. So let me right click on this. 10 to n factorial raised to. Then there is an n factorial. So I've done this, and then there is m factorial, and then there is an n minus m factorial. So covered all this. What is remaining is a 2. So that is 2 raised to n minus m in the numerator, and that is 2 raised to 2n in the denominator. So I have taken care of this. That's factor of 2 has been taken care of. Next is whatever is x and t, x raised to n minus m. And t raised to, from here I have n minus m and plus 2m. Set. I think that's. Let me rewrite this as. Is this visible on the camera? I think yes, very much. Okay, n equal to 0, infinity. This is 2n factorial, mostly copying things down, but just one simplification, right? And this is 1 over 2n minus n, that's n. And then there is 1 over 2 raised to n plus m. And here I have x raised to n minus n and t raised to n plus n. Yeah. That seems to be okay. I have to do this sum, so that is a double summation. It doesn't matter in what order you add these sum. So that is the nice feature you use in this. So you want to reorder this summation process instead of doing n in this order and m going from 0 to n. You want to redo that. So for that, it is good to see a pattern in this. So this is n and this is m. So for each n, so this is your values for n. So this is n equal to 0, that's 1, that's 2, that's 3, and so on. For each of this value of n, m goes from 0 to n. So m goes from 0 to n is 0 itself, it doesn't, so it's just this one. For m, it goes 1 and or 0 and 1. So this is 0, that's 1. Is that clear? For n equal to 2, I have to do 0, 1, and 2. For n equal to 3, I have to do 0, 1, 2, 3, and so on. Is that clear what I'm doing? Ask me questions. And so on. You keep going on top. So that you're basically summing on every point. So every coordinate here is m comma n. You don't add up all the points, you're actually adding up on the upper triangular part of that. So that's just a visual representation of this summation process. If I have to add all these quantities, it doesn't matter when I'm doing 1 plus 2 plus 3, I can also do 3 plus 2 plus 1. The order of addition doesn't matter. So instead of doing the addition this way horizontally, now we will do it in slightly different manner. So let's have some reference lines here. And the same thing. What is the equation of these lines which are actually having a positive slope? If I look for the equation of the lines with this positive slope, I'll say y. Remember, y is equal to mx plus c, right? This m is the slope, right? That's a slope. It's not the same m here. If I think of it in terms of that, y is n, slope is 45-degree slope, so x is m. And the y-intercept is what I want to capture. It is 0, 1, 2, 3. The y-intercepts are 0, 1, 2, 3. that I will call as 2s is equal to 0. That's my y-intercept to s. Here the y-intercept is 0. Here next one is 2s equal to 1. Next one is 2s equal to 2. The y-intercept is 2. Here 2s is equal to 3, and so on. That's a variable I'm using to classify those lines. And now do the same thing on the negative slope lines. N is equal to slope of tangent 45 minus 1, so that's minus m. And again, what is the variable I use here? This I say is L equal to 0. This I say is L equal to 1, L equal to 2, and L equal to 3. Notice that's the intercept line. So this L's are the intercepts of those lines. So this is of L. Is that clear?
Is the 2s, is the 2 up there to ensure that it's always positive?
Tell it again.
I'm confused on why that's 2s.
Oh,
Is that just to make sure it's positive?
no, later on, it will be necessary that I have to divide by 2.
Oh.
If you want, you can use another variable, let's say, t, for example, here is just later on, it is convenient to divide it by 2 in a few steps. At this point, the motivation is not clear as to why did I write that 2. You should have written some single variable, but I am foreseeing what is going to happen, and that's the point.
Okay.
Yeah, so it doesn't matter at this point.
Right.
Questions on what those parameters are? Okay, if that's the case, now what we will do is if I have to add these quantities, instead of doing n equal to 0 to infinity, I just have to go for each L. For L equal to 0, that is one sum. L equal to 1 also, that is only one term. L equal to 2, there are 2. L equal to 3, that is 2. L equal to 4, and so on. So that's the ordering I'm going to do. So for each L, I'm going to go this way. Earlier I was doing for each n, I was going horizontally. Now for each L, I'm going to go in the negative slope line. Is that order clear? So, so the idea is n equal to 0 to infinity and m equal to 0 to n. You switch this to L equal to 0 to infinity, and S accordingly has to change, right? But now I have to say what are the limits on the S? Here it was very clear, it is m as 0 to n. But now what are the limits on S? I have to figure out. So when S is even or L is even, if L is even, then 2S goes from, so let's look at the even ones. 2s here goes to 0, that is L. 2s equal to 2, that is again L. Right, so 2s seems to be going from 0 to like 0, and 2s here goes from 0 and 2. The next one is 0 to 4. Right, so it's 0 to 4, and how far will it go? The farthest point is L equal to 3. It is the L that it is terminating on. So it goes all the way till L. And L is even, notice, so this will always show up there. Right? So 0 to 4 until L. Is that clear? What about L odd? Say 2s this time. It is now L odd. This is L equal to 1, starts from 1 and ends in 1. So it goes 1, 3, 5. And how far does it go? It is always L, right? And L is the choice that we had. So this will again be L. Okay. For this scenario, it is good to see that if I were to subtract 1, so for the odd case, this is the odd case. If I were to subtract 1, then I go from 0 to 4 and go until L minus 1. And it will also be convenient to think that if I divide this by 2, so maybe the same idea goes here also. If I divide this by 2, then S goes from 0, 1, 2, all the way till L over 2. Like if it is even, if it goes to L over 2, and here it goes from S minus half, and it goes from 0, 1, 2 until so this is L minus 1 over 2. Okay, sure. So where does my sum takes me? So I have to change my variables here when if I'm doing it on L. So S goes from 0. Surely the lower limit is always 0. And the upper limit can be L by 2. If it is even, it is L minus 1 over 2, but this is S minus half, so I have to be careful. So I'll just write this as S. So that's understood that this is the summation that is going on in here. That's GT comma X, that's equal to L equal to 0 to infinity. And S summation, there are these limits, which is noted down here, so it's understood that it follows that. Minus 1 raised to M. What is M? So I have to add and subtract here, right? So let me do that. So N plus M is equal to L, and minus M is equal to 2 times S. So if I add them, I get 2 times N is equal to L plus 2S, and 2 times M will be equal to L minus 2S. So N is equal to L by 2 plus S, and M is equal to L by 2 minus S, right? Those are all expressions you can have, but I'm interested in M, so M is equal to L by 2 minus S. That is 2n factorial, 2n is L, 2n L plus 2S factorial. N factorial, N is L by 2 plus S factorial. Then there is M factorial, L by 2 minus S factorial. And that is N minus M is nothing but 2S, right? That's 2S factorial. That is 2 raised to N plus 1, that's nothing but 1 over 2 raised to L. And X raised to N minus M, so that's X raised to 2 times S. And T raised to N plus M is T raised to L. All this so that we could collect this T raised to L. Why did we do all this? What was the motivation? Because remember, we are to get this power as T raised to L. That is the whole motivation, that I want to expand in T raised to L. So this is a very detailed form of why, even visual motivation for why I did that. So if I pull this L out, whatever is remaining is my Legendre polynomial, right? That's what it is. So Legendre polynomial then is PL X is equal to, comparing it with this, if I take out the T raised to L and the L equal to 0 to infinity sum, whatever is remaining is my Legendre polynomials, but it's not very convenient still, because that is the summation I have to worry about. So it is equal to minus 1 raised to L by 2 minus S, and what? Let me rewrite this, sorry. So 2 raised to L can come out. That's one simple thing. Summation over S and X raised to 2 times S minus 1 raised to L by 2 minus S. Then you have L by 2 plus S factorial, L by 2 minus S factorial. So that's few things, and then there is L plus 2S factorial divided by 2S factorial. Right, I think I collected all, and let me write the XS here. Better. Next is a simple idea that derivative d by dx of x raised to m, let's say n and m is all being used up. Okay, just n, let's say this is n times x raised to n minus m. Sorry, n minus 1. If I keep doing this derivatives few number of times, it is easy to see that d by dx raised to, if I do this L times of x raised to L plus 2s. What will I get? So this brings down the power by 1. If I do this L times, it will bring down the power by L. Right? So this will surely be L plus 2s times L plus 2s minus 1 and so on. What's the last power? So I have to go L, right? So 1, 2, help me. So 0, 1, so L minus 1, I guess. So this is L plus 2s minus of L minus 1. Right? X raised to, I've reduced the power by L, so that's 2s. Is that correct that I do? Yes. No. Minus L, right? So this is 0, 1, 2. So this is L. I do this L times L powers come down. So it's L minus 1. Isn't that correct? No, right? Check again. Right? D by let's do this for S equal to 5 and L equal to 2, right? I think this should work. 2x raised to 510 plus 2, 12. So this is equal to 12 times 11 divided by, that's it, right? Times x raised to 10. That's what it should be. That's the same as 12 factorial divided by 10 factorial. So whatever remains, the power remains, that's the denominator. So this is L. Yeah, 2s minus 1 and next one will be 2s. Yeah, that's correct. So this is the same as L plus 2s factorial. Yeah, 2s factorial raised to x raised to 2s. Yeah, so 12 factorial by 10 factorial. Is that acceptable? Can you see that? So that's, if I use this in here to replace that, my Legendre polynomial expression becomes 1 over 2 raised to L times derivative with respect to x raised to L. Since it is not having the s in it, it can come out of the sum. And the sum itself is, and also let me pull out an L factorial. L factorial divided by L plus 2 plus S factorial and L minus 2 over S factorial. And I have a x raised to L plus 2s, so I write that as L by 2 plus s, that's this, and that is minus 1 raised to L by 2 minus s. I hope this was, like, this is reasonably straightforward, so I didn't go through and check all that, but I think you should be able to do that. With me? We are almost there, except that now I have to do this for s equal to odd and s equal to even, so I do that separately. So let's do s equal to even first. So if s is equal to even, we said s goes from 0 to L by 2. So this summation here, so this is equal to s equal to 0 to L by 2, L factorial, divided by L by 2 plus s factorial, L by 2 minus s factorial, and here is x squared. Let's just copy. But now I notice where it is running from. S goes from 0, 1, 2, 3, and so on. But let me substitute here in this sum. L by 2 minus s is equal to n. Okay, that's it. So instead of running the sum from s equal to 0 to L by 2, I can go the reverse. That's what is happening, but that's just a visual way of seeing it. For n goes from when s is equal to 0, then it's L by 2, and it goes all the way to no, that's not what I want to do. Sorry.
Should be L by 2 plus s equals n.
Yes. Is that right?
Because then you get
Yeah, L by 2 plus s.
you get L by 2 to L.
Even.
Yeah, that's right. L by 2 plus s. Yeah, L by 2 plus s equal to 0. Then what happens? Let's see. So then when s is no. So I want to do s minus L by 2 is equal to n, right? So that when s is equal to plus s plus L by 2. Yeah. Let me check. I don't want to mess up it. If I have them. Yes. Yeah, L by 2 minus s is equal to, yeah, that's what I wrote earlier, right? Did I not write that? Okay. Oh, yeah, that's it. L by 2 minus s is equal to n. Right, now let's see. When s is equal to 0, this is L by 2. Or I want to now sum from the top to the bottom, right? So what are the values this can take? So n will be equal to when s is equal to 0, it is L by 2. Then it keeps going, and when s is equal to L by 2, this is 0.
Yeah.
Right. So, but I sum in the reverse order, right? So it is n is still going from 0 to L by 2. Is that clear? Well, it doesn't matter in what order I sum, so I'm writing it in the reverse order. And then you have L factorial remains the same. L by 2 plus s. So it is L by 2 plus s is plus L by 2 minus n factorial. And L by 2 minus s is n factorial. Here this becomes x squared raised to L by 2 plus s was here L minus n. And here it is minus 1 raised to L by 2 minus n is n. And if you notice, this is exactly the binomial expression we had here, n factorial by m factorial n minus m. The powers also match, except that this doesn't go all the way through.
Right, we just keep summing anyways.
Huh?
Can we not just keep summing past that anyways and but we
But then I'm adding something, then it's not equal, right? So let me add it anyway, so I'm going to add it. So this is not really equal, but this is equal to n equal to 0 to let's say L times L factorial by L minus n factorial times n factorial x raised to 2 L minus n minus 1 raised to n minus of the powers that runs from, so I subtract them, right? So n equal to L by 2 with L, and the same thing. So the powers of x squared is to L minus n, right? And there are coefficients here. Is that clear what I meant? But I'm going to show that this really doesn't contribute. But at this point, it does contribute. But after I take the derivatives, it will not contribute. What is this equal to? This is x squared minus 1 raised to L. And what I'm subtracting here, let's look at the powers. This is when n is equal to L by 2, right? So this is L by 2. So this starts from x raised to L plus 1. Sorry, so this is 2L. The 2 times L minus x raised to 2L minus 2n. So L and n, so this is L by 2 plus 1, right? Because we have gone from until L by 2, this is L by 2 plus 1. So L by 2 cancels out, that's x raised to 1. Next one will be 1, right? 1. All right. Help again. X raised to 2L minus 2n. So 2L minus 2 times L by 2 plus 1. So that's 2L minus 2L plus minus 2. That's wrong, right? Is it wrong? How can it be minus 2? Hold on. Again. Did I write this correct? Yes, L minus n, that's correct.
Yes.
So L minus of L by 2 plus 1. So that's equal to L by 2 minus 1. Right, so it's L by 2 minus 1. So this is, yeah, so it is not negative, so it is x raised to L by 2 minus 1. The next power will be x raised to L by 2 minus 2, and so on. So, but notice this is having a derivative with, this whole thing is acted upon by a derivative with a power raised to L. So the highest power is L by 2, so this will not contribute. When you take the derivatives, this will go to 0. So all these terms will go to 0, doesn't contribute. So this goes to 0. So it is x squared minus L, so this whole thing acting on that. What about S equal to R? 7 minutes. It's pretty much the same idea, except that now you're going from L minus 2, right? 2S minus 1 and going from L minus 1 over 2. So let's substitute first of all, S prime is equal to S minus half. So the summation here is 2S minus 1. So it is S prime going from 0 to L minus 1 over 2. And rest everything remains the same. So it is L factorial divided by L plus 2 plus S, but S is S prime is S prime plus R.
L by 2 minus 1 or L minus 1 by 2?
We said L minus S minus, so I'm substituting S prime, yeah, this is S prime.
Okay.
S prime goes from 0
To L minus
to
1.
L
Yeah.
prime, L minus 1 over 2, right? That we were clear about. And now I'm doing the sum, maybe I should do this in 2 steps. So if the sum was on S, so first let me write it for S. It is L factorial divided by L by 2 plus S factorial, L by 2 minus S factorial. X squared raised to L by 2 plus S. That's equal to, I have to replace all the S's with S primes and do the sum for S prime. And S prime runs from 0 to L minus 1 over 2. So this is L factorial divided by L by 2 plus S is S prime plus half. So this is S prime plus half. So that's the same as L plus 1 over 2. This is the same as L plus 1 over 2 plus S prime factorial. And here it is L S will have a 1 there. So it is S will have a 1 there, so it is L minus 1 over 2 plus S prime factorial. And you have x raised to x squared raised to L by 2 plus S is L plus 1 over 2 plus S prime. This is minus 1 raised to L by 2 minus S is L minus 1 over 2 plus S prime. Same idea as before. Where was this? I have to redo this sum, but this time I will say it is L minus 1. So the n now is L minus 1. So it is, there's a power of minus 1 that was important. So it is L minus 1 over 2. No, this is minus, right? Minus S prime is what you call Sn. This is equal to n.
In the second part of the denominator, L minus 1 by 2 minus
Minus S. Right? Thank you. Minus, that's good. So this is n equal to, again, goes from 0 when S prime is L minus over 2, so that's equal to 0. And the maximum value is when this is equal to 0, so it's L minus 1 over 2. Otherwise, most of it remains the same. So this is L plus 1. This means this gives you L minus n factorial, and this is n factorial, and x raised to 2. Your L plus n, or L minus n, and this is minus 1 raised to. And again, this the powers that there are higher powers in this, but the derivatives kill that. So this is x squared minus 1 raised to L plus powers that powers lower than L, plus powers lower than L, which doesn't contribute under derivative. So maybe the way to say it is that here plus powers of x lower than L. Because when I take L derivatives, that will not contribute. overall, all this means that for both odd and even, I have my Legendre polynomials defined as 1 over 2 raised to L, 1 over L factorial, derivative of x, L derivatives of x, and then x squared minus 1 is to L. One last thing, remember x was nothing but gamma, right? Let's write this as cosine theta. So 1 minus x squared then is sine square theta. And derivative with respect to x. So partial derivative, let's say partial derivative with respect to x will be partial derivative of cosine theta with respect to x, and then derivative with respect to theta. Derivative of what did I do?
It shouldn't be.
Cosine theta, right here. Chain, right? And derivative with respect to x, right? Cosine theta with respect to theta is minus sine theta d by dx.
Should there be
Oh,
a sheet
This
there,
is
but
theta, right? Better? No? So, okay, let's say we are doing d by dx. That's the same as d theta by dx, and then d by d theta, right? So this is only having one variable, so dx by d theta by dx is the inverse of that. So dx by d theta, there's only one variable, otherwise this is not true. And that's minus sine theta, that's fine. Minus 1, so that's equal to minus 1 over sine theta d by d theta. Better. That's it for sure. Okay. So what that means here is that this Legendre polynomial, give me one more minute, and this is equal to 1 over 2 raised to L, 1 over L factorial. It is also convenient to write this as minus, or there is a minus 1 raised to L. D by d theta raised to L, and x squared minus 1 is sine square theta. That's sine theta. And there's the L, so I think this is just an L. Isn't that correct? X squared minus 1 is 2L, I guess. Sine theta raised to 2. Check the minus 1s. So there was surely a minus 1 raised to L, and then x squared minus 1 is minus 1 raised to L again, but that goes away, I guess. I think so. Hopefully that's visible. Is it readable on the board there across the internet?
It's okay if you're following along, you know what you're writing.
I see. Otherwise, not necessarily, right?
Right.
Like. Okay, that's all. So this is called the Rodrigues formula. So you can generate it whenever you want to, but these days,
It's very hard to generate.
Huh?
It's very hard to generate.
yeah, otherwise you'll have to do the, if I ask you, okay, give me P4x, you'll have to expand the series, but this is much easier, you just have to take the derivative. So that's some of the things that I can ask in the exam very easily, right? Give me P5x, that's 5 minutes or 3 minute job as it were, right? Like you just have to take derivatives. That much I expect.
But hopefully not deriving.
No, but now that I've spent 2 lectures because of my mistake, any of the small pieces in this goes as a good exam question, especially the one that we struggle in the beginning. I spent half an hour for it. It is supposed to be like probably high school student, right? Like in high school, we do that. So something like that, which I spent a lot of time in the class, so that becomes an exam. Is that clear? Some summation that we did. Remember, like I think it was this expression. So starting from here, reach there, something like that. But I had to come up with a question that is doable, right? I should be able to phrase it properly, and it shouldn't be confusing. So
Oh, I'm worried that if you had a hard time with it, I'm gonna have a really hard.
see, that's no. Okay, here is my point. This is supposed to be easy. This is my mistakes. And I was a little intimidated because I made a mistake last time. I don't make mistakes usually. So I was intimidated, but okay, how about this? There will be a question from the derivation here, for sure. I intend to. That's what I thought in the morning, that okay, I'm going to repeat this. So I'll ask something small on this, but something small. So for example, for even, do from here to there. For the even sum, do this from here to here. From odd, like each one that is doable in 10 minutes.
Yeah.
Is that clear?
Yeah.
Or maybe 15 minutes. And if you struggle, maybe half an hour. Right?
Yeah.
Like students tend to make mistakes. I make mistakes. So, but I'm saying I expect this.
Okay.
So that Ian, your comment that if I struggle, then you will struggle, that's not an excuse. Okay.
Thank you.
You have to know it.
One question.
So